Hello everybody, this is Mr. Yen, and in this video I'm going to be walking you through lesson 8.4, Translated Lines, and I want you to think of this video as a help video instead of an instructional video, because I want you to watch it actually after you've completed as much of the lesson as you can, instead of watching this video before. So if you're watching this video first, I want you to pause it, do as much of the lesson first, and then come back to the video to check your work. Okay, so in the problem we have two runners. We have Fernando and we have Mariah, and we have information about how many laps they have run at different time intervals. So starting with Fernando, we want to graph his data on the right here. And so we know at 0 minutes he has 40 laps, and then he's running a certain number of laps every 10 minutes until he gets to 65 laps at 50 minutes. To graph this using Google Slides, I'm going to click to the line tool. That's here. And so we start at 0:40. So I'll click here, and then I'm going to drag. And I know that at 50 minutes, he has 65 laps. So I'll bring that here to 50 and 65, just like that. And then you can adjust your line if you need to by clicking and dragging either of the corners. I'm going to give this some color just to make it look grand. Okay, so this blue line that I just drew in, that is Fernando's data. Next we have Mariah's data. Mariah's data is represented by this line on the graph, so I have to fill out the table. From looking at this line, I know that at 0 minutes she has 20 laps. At 10 minutes, she has 25. At 20, she has 30. And I can start to see the pattern. It's going up 5 laps every 40 minutes. So I know at 50 minutes, she has 45 laps. Okay, now Mariah's table is filled out. The first question asks us, how is Fernando's running data similar? Well, if I look at the graph, I can see that the two lines have the same slope. And slope is like their rate. So if they have the same slope, I know that they must be running at the same speed. So I can say both runners run at the same speed. And I can even be more specific here and say what that speed is. And I know that Fernando, every 10 minutes, he runs 5 more laps. Mariah, every 10 minutes, she also runs 5 more laps. So both runners run at the same speed of 5 laps every 10 minutes. You can even simplify that. 5 laps every 10 minutes. If I divide both those numbers by 5, I would get 1 lap every 2 minutes. Okay, so both runners are running at the same speed or the same rate. That's what's similar. Well, what's different? Going back to the graph, or just looking at the table, I know that their numbers are not exactly the same, because they're not the same line, and the tables aren't exactly the same. So they are different because the difference between the two is I know that Fernando, because his line's always on top, that he's always going to have a certain number more laps. In this case, he started with 40 while Mariah started with 20. So Fernando always has 20 more laps. Okay. Number 3. A slope-intercept equation for Mariah. Remember, slope-intercept form is this right here. Y equals mx plus b, or f of x equals mx plus b. M is the slope, b is the y-intercept, the starting place. So for Mariah, we know that her slope is 5 laps, because laps is y, x is time, so 5 laps every 10 minutes. You can also see that on the graph, it goes up 5 and across 10. right here. So the slope is 5/10. Write that as a fraction, plus the y-intercept where she started, that's right here. She starts with 20 laps. 5/10, I can simplify that to 1/2. So I know that Mariah's equation is 1/2 times, actually I want to use the variable t here because it's m of t. 1/2 times t plus 20. Okay, Fernando, we know Fernando has the same slope or the same rate as Mariah, so that's also going to be 1/2 t plus, let's check his y-intercept on the graph. At 0 minutes, Fernando starts with 40 laps right here, so 1/2 t plus 40. Okay, now we have this slide. Let's check the next one. Okay, these are the same two graphs for Fernando and Mariah, so it's the same set of data. Fernando runs at the same rate as Mariah, that's what we concluded. However, Fernando, well, what's the difference? We've actually already said this. Fernando always has 20 more laps than Mariah. Okay, so now it's asking us to complete the function that's going to combine Fernando's function, which is f of t, with Mariah's function, which is m of t. So we see how it starts with f of t is equal to m of t with some modification. Well, let's think about what we're saying in the previous problem, that Fernando runs at the same rate as Mariah. So that's like saying Fernando's function is the same as Mariah's function. However, Fernando always has 20 more laps than Mariah. Fernando's line is always 20 units above Mariah's line at any given time. So to put that in function form, I can say Fernando's function is equal to Mariah's function. However, he always has 20 more laps. So I can combine these functions by saying f of t is equal to m of t, but plus 20. Now they're equal to each other once we add in the 20 more to Mariah. Okay, next, how could you transform the line of Mariah's equation onto the line for Fernando's equation? Let's check the graph. We know Mariah's line is this red line, Fernando's line is this blue line. And this is great in Google Slides because you can even just click on the line and then use the arrows. So all I have to do is, to get Mariah's line, the red line onto the blue line, is just press up a couple of times. And notice how, once I do that, it lines up. And how many units am I going up exactly? Well, let's check the graph. Her y-intercept was 20. Fernando's y-intercept was 40. So this line has to go up. It has to be translated up 20 units to land right on Fernando's. Okay, so I can say Mariah's line can be translated 20 units up to be on Fernando's line. Other way around for number 8, how could you transform Fernando's equation onto the line of Mariah's? Well, if we take Fernando's line, he has to move a certain number of units down to be on Mariah's line. How many units down? Well, we're going from a y-intercept of 40 to a y-intercept of 20, so it's going 20 units down. Fernando's line can be translated 20 units down to be on Mariah's line. And then the last question, how can we combine Mariah's equation with Fernando's equation, except this time with Mariah being the first one? So this, you can read this as Mariah's equation is the same as Fernando's equation with what modification? Well, if we know that Fernando's line has to be translated 20 units down in order to be on Mariah's line, that means we would have to subtract 20 from Fernando's equation in order for his to be equal to Mariah's. Another way you can read this is Mariah's number of laps is always equal to the number of Fernando's number of laps at any given time minus 20. She always has 20 less. Okay, that's all you need to know. And with that, I will say goodbye and good luck.